And we're back here. Now I need to figure out where we were before. I think we're doing the text part. That file text. And yeah, I need to be able to load a JSON file. But in order to load a text file, I need to be able to parse it into a series of tokens. That's what a file parser does. But this means I have to create a set of tokens. Means I have to figure out how to do tokens. Okay, that's gonna take a while. Okay, file new. File. Okay, HTML file. Visual supposed to edit file. Okay. Okay. If and def type token. Okay, and I need to know how a token is supposed to work. Okay, it's a linked list. Well, it's not a linked list, it's a tree. I need to define how to do a tree. So you have to be able to insert tokens. Okay, and if. Okay, and if. Okay. So now I need to figure out how to insert tokens. Okay, define the token. Type def structure. No, I can't type right now. Type token. Okay, how does a token work? Okay, first we need a type. Okay, unsigned long token type. What else? Unsigned long, not. Oh, it has to be void. Yeah, void. Token data. Yeah, token child. You need a series of child nodes. Okay, I have to figure out how to do this. Unsigned long, and within each child node is a linked list, so it has to be void. Token next. Okay, so how does this work? Okay, the child part is a list of is the beginning of a linked list. The next part is what each token is part of a linked list. So that's the first token and the next token from the linked list, and then the child node is the beginning of another linked list of children. So this forms a tree. So we need to figure out how to insert it. Okay, void type token and insert. Okay, type token parent, and then the one that you're inserting. Parent and type token value. Okay, how do we insert into a token? It should be very simple in theory. If parent equals 0, return 0. I have to check that. In theory, it should be very simple. Okay, parent, no, value dot token next equals parent dot token child, and next is parent dot token child equal value. Return 1. In theory, that should be just it right there. But in practice, we run into several problems here. First of all, what if the value is already a child of the token? Then we have a loop and the whole thing breaks. So that won't work. Okay, we have to check if value. Okay, value equals 0, return 0. Okay. So first you have to check if the value is already inside the token. Okay, type token is child. Is it a child already? Is child. Okay. Okay, if parent equals 0 parent equals 0 equal return 0. Okay. Okay, now we have to traverse the entire parent to check if the child exists. So we need another token working. How do we traverse the parent? Is working. Okay, working equals parent dot token child. Easy enough. While working, okay, working equals working dot token next. Okay, now we check if working equals value, then we turn 1. Oh wait, no. Oh, return 1. Okay, okay, 1. Return 0. So now we're able to check if the token, if this token that we're inserting is already a child of the token. This is to avoid any kind of loops. Okay. If parent.isChild return 0. Value return 0. We cannot insert a child that's already a child. Okay. Okay. There's also a possibility that the token and the parent are the same. So probably not gonna happen, but let's check anyway. If parent equal value return 0. Probably can't happen, but I'll just put it up here. Since we're gonna have to do the check anyway, so let's just go do everything in one function. Okay, if parent equal value return 0. Whoa, return. Oh crap. That's a problem. That doesn't matter. Oh, that's good. It's a problem here. If parent equal value, then it is not a child. So we try to insert it anyway. Oh, that's a problem. No, we can't do it here. So we have to account for every possibility. So that wouldn't work here. Is it a child? Yes. If parent equal, if working equal value, then it is a child. We have to check every possibility. Okay, to insert. But here's a problem again. Since we're doing a file parser, then the order of that we're inserting it matters a lot. So we can't just insert at any point. You have to insert at a specific point at the last position. Okay, so now we need to insert last. Okay, that's insert first. Okay, this right here is insert first. You insert at the first position, but since we're doing a file parsing, any entity we insert has to be inserted at the last position. So let's just call that one insert first. Insert at first position. Okay, now we need to insert that at the last position. Okay, so how do we do this here? Okay, insert last. Okay, the easiest way to do it would just be to traverse the entire thing again, but we're already checking is child, so it would just be easier just to make sure, just to go through the entire list and then just insert at the last position. That would be the easiest way to do it, and it already makes sense. We're already traversing the list anyway, so it really doesn't make any difference. But I don't like the way you do it. I don't like that way. So I'm gonna do it a slightly different way. Okay, first of all, I prefer to count the number of children. Let's just add a few things here. Okay, unsigned long. Token child count. Count. How many children does the token have? Okay, next. Okay, we need to know what the last child is. Since we're going to do this anyway, it doesn't really matter. Let's do it the simplest way. Otherwise, I'm just going to be this forever. Okay, so we don't need this. While working.file, if return 0, let's reverse this. If working equals value, return 0. Then we just go through everything here until working equals 0. But we need a previous. Okay. Here we go, working and previous. Okay, let's just do it the simplest way. Previous equals 0. Okay, previous. Okay, so we're just going to do everything in finding out which one's the last node, while at the same time checking which if the node already exists in the list. Okay, so now that we know that it doesn't exist, if previous equals 0, then we do everything as normal. Parent equals child, parent.child count, token child count, plus plus. Okay, token.child count, plus plus. But if previous does not equal 0, else, then something slightly different here. Okay, previous dot token next. Okay, previous. What previous will always be, the previous of the token next is always going to be 0, equal value. And actually that's it. Everything assumes that all the items in value are already set to the right values, and that may not be the case. So things can get a little bit complicated here. So this is the simplest way you do it, but it's not the right way to do it at all. It's very ugly. I'm just going to it just to show that it works. Okay, so inserting at the last position here. Okay, so if previous equals 0, then we just set previous to token token next equal value. That's so far it's very simple, but I really don't like the way it looks. Let's just go to all of them anyway. Insert last. Okay, next. Insert. By the way, I got these names of jQuery, and just every type of node function that I can think of, I'm just gonna put them in there. We'll do modifications later. Insert after. Okay, insert after what? After selector. After a certain position, selector. Okay. We still need to check if it's child, if token is child, and I got noise. Okay, I was still in the right position here. Oh, okay, we need to check if it's child. If it's child, return 0. Okay, how do we insert after a certain position? This should be difficult. If working equals selector. Selector, okay. If working equals selector, then not return 1. It's we have to check what we're doing here. Return 0. This way we return 0. If working equals selector is, how do you do? Okay, working. No, it's not working. Parent. Not parent. Parent won't work. It's working. No, it's I keep confusing myself. Value dot token next equal working dot token next. If the selector doesn't exist, then it really doesn't matter. Then we just return 0. Then we don't care. If the select, okay, I need to figure out what I'm doing here. Okay, if working dot token next the value token equal to previous. We don't need previous. Okay, value token equal working token next, and working token next equals value. And of course we increase the number of children. So far so good, but it's still too ugly to work. I'm just gonna keep going. Return 1. Okay, value.token next, working.token next, working.token next value, parent.child count plus plus. If the selector doesn't exist, we just exit. Okay, let's keep going. Next, insert at. Okay, actually before insert that, let's just say insert before. Insert before a specific position. Just gonna do everything the same. And okay, just gonna copy everything the same. Well, most everything. What am I doing? It didn't copy right. Okay, previous. Just go to everything. Just copy everything. We'll deal with the rest later. Okay, previous equals 0. Okay, insert before selector. If working equals selector, on a previous. I didn't remove this. Okay, previously we're working. If working equals selector, then and if it then matters. If previous equals 0. If the selector is the first one in the list, then we have to do something different. Okay, now I'm trying to figure this out here. Parent. No, it's value.token next. Value.token next equals parent. Okay, parent.token child. Parent.token child equals value. By the way, the reason why we do it this way is we're keeping the pointers. We're keeping the pointer of the first child because it's a linked list. Is saving into value and then setting it to the. We're setting the next value. We're transferring the list into the next value of the token we're inserting, and then we're saving the list as the first as the first item in the list as the value itself. And at the end, we're incrementing the number of children. So this should be easy enough. Else, and copy this into here. But that won't work. It's previous. Working as previous. Okay. No, here. Previous equal working. Okay. So everything right here is mostly the way it should be. Maybe there's a mistake, but we're just going to delete everything later, so it doesn't matter. Okay, next. Okay, insert before, insert at. Insert at. Okay, that's what it's called, but I need to figure out exactly what it's doing. Insert at is a specific index. Unsigned long index. Insert at. Insert at specific position. It's mostly the same thing, I think. Actually, it's almost exactly the same thing. Copy and paste. Okay. Now we need a counter. Whoa, Okay, that's bad. Okay, that's bad. X paste. Okay. Okay. Unsigned. Oh wait. Insert at is it's same as insert previous. Oh, we should be copying this one, not the other one. Insert at. We need to insert at specific position. Okay, so we copy this one and we add a counter. No, no. Oh, come on. I can't type. Unsigned long. Counter. Okay, counter equals 0. And counter plus plus. Now we increment. What is? Oh, it works. If counter equal index. Okay, equal index. Okay, we're setting at the value at a specific index inside the parent. So far it looking like everything's working, but of course that's not really true. And now we're encountering a few little problems again. Okay, we have each child, insert at first position, insert at last position, insert after, insert before, and insert at a specific location. There are probably more I could do, but that should be enough. But now let's correct a few things here. First, having a child is not enough. We need a parent. We need to update this. Parent. Okay. How to get a specific parent? Okay, I'm reading in at this here. Insert a child. Each child work the same. Okay, it's not enough to just set value.token child. Actually, it's very simple. It's value. Am I in the right place here? Yeah, I am. Value dot token parent token no parent equals parent. Easy as that. Okay, is everything right? Okay, there's another problem I remember having with this. Can't remember what exactly it was, but we need a first child and a last child. I really don't like the way it looks. I'm gonna do something slightly different here. Instead of inserting by going to a list every single time, I'm going to do a last child to a pointer to the last position. I'm just going to modify it here. Okay, token child is first child. Just cause some cosmetic work, because I really don't like the way it looks. Okay, now for last child. Okay, and also token init. We need to be able to set to 0. Now the reason why I don't just create it to set it to 0 is I need extra data to add to the token. And in fact, I just add it now. Token data. Okay, token data size. Token data. The reason is when you're parsing a file, that it may a token JSON file, it may contain a number, a list, or a string. So we need to be able to add the string at the end of it. We allocate the entire structure, and then we allocate extra memory to add the string at the bottom of it. Last child is the data size is the size of the extra data that we need to know the size of the token plus the extra data that we're adding. Okay, so now we need to initialize the token. We can't just create it or destroy it because we don't know how much data is going to be added at the end. So we need just to initialize it. Oh, wait, I'm inserting. Oh, I just typed a key I wasn't supposed to. Okay, I just set everything to 0. Actually, no, memset. I may be adding no stuff, so I don't want to have to set everything to 0. Okay, memset. What does the memset work? Parent. No, parent 0. Size of type token. Type token. Okay, we don't need that. Okay. If parent equals 0, return 0. Okay. If parent equals 0, return 0 and return 1. Okay, what else do we need to do instead of initializing? It doesn't matter. We'll work this out later. Okay, memset. What is memset comp? Why doesn't it like it? Okay, stdlib. Okay, include. Oh no. stdlib.h. Okay, it still doesn't like it. Okay, also string. Okay, I just have to figure out why it doesn't like memset. Memset. Search online. Oh, memset. Okay. Memset C string. What is this? That doesn't matter. Okay. Where are we? Okay, just set to memset is child. Okay, this one's good. But I need to modify this one to fit into the something different here. If token is child, parent.token child count, put that on top. Okay, parent.token value.token parent. Okay, we have first child and last child. So we need to figure out a better way to insert it that doesn't involve just traversing the list every single time. That just doesn't make sense. Okay. If parent dot token is it first child or last child? Parent dot token first child. Okay, insert first. Oh, parent dot token first child equals 0. Parent dot token first child equal value. Oh, so if there's no children, because we need to know what the position of the last child is. If there's no children, then both the first child and the last child are the same thing. Okay. Parent dot token last child also equal value. Okay, that's the first condition. Else, they're not the same. This is going to be difficult here. I'm trying to think this through and it just doesn't work. Okay, value dot token next equals parent dot token child. Token first child, not token child. First child. Okay, value dot token first child. But parent dot token first child. Oh, this may be more complicated than I thought it was. Okay, insert first. Parent dot token first child equals parent dot token first child equal value. But no, parent dot token last child. I'm trying to figure out if token last child needs to be something else, but I don't think it does because it's already pointing someplace else. If token first child is not 0, then the parent dot token last child points nowhere. And then it points to the last child, but we don't need to deal with it because it points to something completely different than what we need to deal with here. Ah, okay. So we don't need to worry about this one. Okay, so I'm trying to do something very complicated here, and it's really hard to keep track of where everything's supposed to be. Okay, insert last. This one's going to be a slightly more complicated. Okay, if parent value equals 0, if parent, oh, wait. This is what I need to remove. Because I don't like having this, all this traversing the list and if previous, and it's just too ugly. Okay, okay, if, okay, same thing as before, slightly same thing. If parent dot token first child, okay, actually everything here is the same. Except for this last part, else. Okay, I'm trying to think this through here. So here we don't need to worry about it, but here is the only thing we need to worry about. Okay, value. Okay, value token. I think this is the same. I think it's the same here. Value dot token next equal parent dot token first child. Okay. Oh no, that doesn't work. What am I thinking about this? I'm thinking about something completely different here. Okay. Parent dot token first child equals value. Parent dot token last child equals. Okay. Oh. Okay. Okay. Okay, we need to modify what the last child is. Okay, parent dot token last child equal value. But that doesn't work because the last child is something previous. So we need to modify what the last child is to point to value. To point to value before we can do anything. Because as we add new tokens, the last child will keep moving down. So it really doesn't matter. But we can just modify this right here because this is the necessary value that we need to deal with. Oh, actually we have this right here. Okay, we need to save it. Working equals parent.token the last child. Okay, so we need to save it and so that we can modify it. Okay, working dot parent.token dot next equals value. What did I? Oh, I didn't want to have to deal with that. That's why I need to deal with that. Okay, working u.parent.token next equal value. Well, it's there. Might as well use it. So we're pointing the last child to the new value, and last child becomes the new value. Okay, trying to work this out in my head is really complicated here. Okay. Parent.token last child. We actually don't need working here, but having parent.token last child dot working dot token next, just don't like that. More than just doing it twice. Okay. Okay, I'm just trying to work this here. Ah, it's a void value, so it doesn't work. It really doesn't work, so we have to cast it. That's what, now I realize that we have to cast everything. Oh, that's so complicated. Now we have to cast it because all the workings are void. So Visual Studio is just going to keep complaining about everything. So let's just modify this here. Okay, so you have to cast everything to the right values. Otherwise, Visual Studio is just going to keep complaining about everything. Okay. Did we have this? Parent.token. Parent, that's a void, so it doesn't matter. Parent.token first child equal value. Parent.token next. Oh, that doesn't matter. No, this matters. Okay, parent.token parent. It's all void value, so it doesn't matter. Doesn't matter. Ah, now that's why it makes sense. This makes sense here. So we need to cast everything to a type token before we can modify anything. Okay, value.token parent equal parent. Everything here. Okay, parent.token first child. Whoa. There's a lot of stuff here that that's really hard to make sense of. We need to cast everything to the proper values, otherwise it's just gonna keep complaining. Token child, if token child, otherwise it just won't work at all. Token last child, that's a void value, doesn't matter. Value the token next is actually it's a void value, so it doesn't matter. First child equal value. Okay, so this works. Okay, I'm just making sure that everything is working the way it's supposed to. Okay, insert after. Token is child. So what are we doing? Insert after. Actually, insert after. Okay, why does the after come before? Why are they inverted? I don't understand that. Not X. Before comes before after. Okay, insert after. Insert before. So how does this work here? Okay. Insert before. How do we insert before? We have to go through all this again, I think. If token child, if working equals selector, previous equals 0, we have to go through this. Bind the token child. There has to be an easy way to do this. Actually, that's just insert first. Let's just insert first. We don't need to go through all this. Insert before, so just insert first. If previous equals 0, just insert first. We don't have to go through all this. Okay, parent value. Insert at first position. Else bind the token child count plus plus value the token next. We set the parent. Okay, I'm trying to work this out here. Most of this is just cosmetic, but it's still very complicated here. We set the parent to the correct value. Value the token next equals previous the token next. So we're not doing first or next. And then previous the token next equal value. But I still spot a potential problem here. So far it's looking good. We just enter that specific position. But what if that specific position is the last value? Okay. Actually, it cannot be the last value because otherwise the working will be 0. So it's insert before. Insert before doesn't matter. I was thinking if this position is the last possible token, but it can't be because previous is not 0. It's not next. Okay, so that's not a problem. It looks like it could be a problem, but it's not a problem. We have to traverse the whole thing twice. Okay, now we do insert after. Hopefully it should be slightly easier. Okay, I forgot selector. Selector. Okay, if selector equals 0, I'm trying to make sure that no hidden problems are showing up here. If token is child returns 0, now you have to go do this again. Working the token child, it's exactly the same thing. Okay, if working equals selector, now we have to decide what we need to do here. Working the token child count plus plus parent dot token what is it? Token parent. Actually, it should be the same. Mostly the same. Okay, the parent dot token parent equal parent. Value dot token next equal preview working. working.token next, and working.token next equals value. But there's a problem. Oh wait. Next problem is I need to cast this. The correct value. Slight issue. Very slight issue, not a big problem, just something we have to take into account. Now there's a problem, a potential problem. We have to make sure that working is not the last token, because if it's last token, we have a problem. If working equals parent token last child, then potential problem is showing up here. Else okay, we need to figure out how to deal with this. If working equal parent token last child, and insert, oh, same thing here, insert last. Insert last. Haha. So that's what I gotta do, just to make sure that the first child and last child are in the same position, are in the right positions. Okay, next. If previous equals 0, counter plus plus. If counter equal index, previous equals 0, then we insert first. Same thing we did here. Insert first. Insert at specific position. Insert first. We're inserting our previous position. It's the same as insert before. Insert add is basically the same as insert before, except that selector is an index instead of a specific value. Okay. Insert first at that specific position. Now we need to copy this. No, we don't need all that. Okay, everything here is the same. Token parent value.token next equal working.token next. No, it's not working.token next, previous.token next. Make sure you don't get this wrong here. That could be painful. Make sure to cast everything to the right values. Okay, working.token next. Working. Just make sure that nothing's missing. And painful as it is, I think that's it. Just save it. Make sure everything's right. Where am I? Visual type library. Okay. Type. Make sure that everything's in the right place. Hopefully we didn't mess anything up. Let's test it. Make sure that we didn't mess anything up here. Nope. Type token. Next time we're gonna start doing JSON stuff, but for now, we build. I'm just gonna test to make sure I didn't mess anything up, and if there is, I'm just gonna correct it. Okay, I've been through this, and I think there's no errors here. Just initialize, check if each child, insert first, insert last, insert before, insert after, and insert at. That's pretty much it. Next time we're gonna start try loading it and saving a JSON file. So I think everything's good now, but it's just gonna get really difficult later. I can sense it.